I am going to teach you graphical method. Let us take a payoff matrix where player 1 has 4 rows and player 2 has 3 rows, 3 columns. The first step always is row minima and column maxima. Row minima, first row 3, circle right outside, second row 5, circle right outside, third row 4, circle right outside, and fourth row -2, circle right outside. For the column, 6 is the highest number, 6, box it right outside, then you have 9, box it right outside, then you have 7, box it right outside. The saddle point is not right because the circle and the square and the box is not in the same cell. As the saddle point is not right, the players adopt mixed strategy. Now let us apply the dominance rule to reduce the matrix. Compare any two rows. If I compare row 1 and row 2, 3 is small, 3 and 6, 3 is small, 8 and 9, 8 is small, 7 and 5, 7 is big, so I cannot cancel. Row 1 and row 3, 3 and 4, 3 is small, 8 and 5, 8 is big, so I cannot cancel. I can compare row 2, R1 and R4, 3 -2, -2 is small, 8, 4, 4 is small, 7, 3, 3 is small, which means R1 dominates R4, hence remove R4 because we are going to remove the smaller row. So after this process, player 2 has 3 columns whereas player 1 now has only 3 rows because the fourth row is eliminated. 3, 8, 7, 6, 9, 5, 4, 5, 6. This is the reduced matrix. Again, apply wise or column wise, it's your choice. Let me try column wise. 3, 8, 8 is big, 6, 9, 9 is big, 4, 5, 5 is big, which means column 2 dominates column 1. So column 2 dominates column 1. Remove column 2. We remove column 2 because it is the bigger column. Row wise smaller row, column wise bigger column. Which means now we have got a reduced matrix with 3 rows and 2 columns, R1, R2, R3. Player 1, R1, R2, R3, and player 2, C1 and C3. The values are 3, 6, 4, 7, 5, 6. 3, 6, 4, 7, 5, 6. Now we can try row wise. 3, 6, I am comparing row 1 and row 2. 3, 6, 3 is small, 7, 5, 7 is big, I cannot cancel. I will compare row 1 and row 3. 3, 4, 3 is small, 7, 6, 7 is big, 7 is big, I cannot cancel. I will compare R2 and R3. 6, 4, 4 is small, 5, 6, 6 is big, I cannot cancel. Which means I am not able to eliminate a row. If I am eliminating a row, I will get a 2 by 2 matrix, I can employ the formula. But here I cannot eliminate a row, so I am going to teach you another method which is called as graphical method. For a graphical method, I have taken a graph sheet. For this graph sheet, I need to have only y-axis, x-axis is not needed here because there is a basic condition for graphical method. Either the row or the column should have only 2, which means there should be either 2 rows or 2 columns. In this case, we have 2 columns, so I can employ the graphical method. Even in the graphical method, I am going to use only the y-axis No x-axis is required here. I have drawn two y-axis. The first y-axis is referred as player 1 and the second y-axis is referred as player 2. Here in the problem I am going to call C1 as P1 and C3 as P2. So once this y-axis is ready, you can number it from 0, 1, 2, 3, 4, 5, 6, 7. Similarly on the other one also 7, 6, 5, 4, 3, 2, 1 and 0. Now let us take the values in pair. C1, C3. C1 is P1 and C3 is P2, which means C1 is 3, P1 is 3 and P2 is 7. P1 is 3 and P2 is 7. Connect these 2 points with a straight line. Connect these 2 points with a straight line. I have connected these 2 points. One line is ready. Now the second one is 6 and 5. P1 is 6, P2 is 5. P1 is 6 and P2 is 5, which means I am going to connect these 2 points. 6, oh my god, sorry, 6 to 5. And the third one is 4, 6, which is 4 and 6. And 6. Now we are done with the graph here. Always go with player 1, P1. This is a column wise graphical because there are 2 columns, so I can call this as a column wise graphical method. Go for the highest starting point of player 1, which is 6. So from the 6, start shading upwards. Keep going till this line intersects at some point, and there is an intersection here, and from this intersection carry on with that line which is intersecting. I have shaded an area which is called as higher envelope. Once you get the higher envelope, in the higher envelope you just check out how many intersections are there. In our problem, in our case, we have only one intersection. If there are more than one intersection, choose the intersection which is at the least point. Higher envelope, least intersection point. In this case, only one intersection point. So that is going to be the direct answer for us, which is 6, 5 and 3, 7. Though I read it as 6, 5 and 3, 7, I should write as given in the sum. I cannot write 6, 5 below that 3, 7 because 3, 7 is originally above 6, 5. So I should write as 3, 7, 6, 5. Do not change the order of the values because your A, B, C and D should not change. Now you can apply the formula, find the value, then find P1, P2, Q1, Q2 and get the solution.